Hello everyone. In this lecture, we are going to discuss about an example for deterministic pushdown automata. So DPDA, we have already seen WW reverse in the previous example, previous video. WW reverse means it is a non-deterministic PDA because we cannot determine the mid part, that is half of the input string. But WCW reverse, here the center marker, center C is given and W is in 0 plus 1 to the power plus. So W can be framed by zeros and ones, any number of zeros and ones. It should be followed by C, the center C, and it is followed by the reverse of W. Reverse of W is 110. So this is also a palindrome, but odd length palindrome. Here the center symbol is C. So it is deterministic PDA because whenever we have got until we have seen C, we have to perform we have to insert all the symbols onto the stack, right? So initially the stack will have Z0. If the input symbol is either 0 or 1, just we need to perform push operation. Just we have to push all zeros and ones onto the stack until C is the input. If C is the input, then just we need to change our state from one to another, that is Q0 to Q1. And for the remaining input, we have to perform match match. The remaining input symbol should be matched with the top of the stack and pop should be performed continuously. So 1 is matched with 1 and this 1 is matched with 1, then 0 is matched with 0. So if we reach Z0, then the input string is the correct input string. So Q0 is the start state. Consider 0, 1, 1, C, 1, 1, 0 and the stack has Z0. So we will be in state Q0 and Z0 is the top of the stack. Current input may be either 0 or 1. So Q0, 0, comma, top of the stack Z0 means we have to push 0 onto the stack. Sometimes our input string may be 100C 001. So it may start with 1 also. So 1 comma Z0 means we need to push 1 onto the stack. And after pushing one input symbol onto the stack, the stack may be either 0, the top of the stack may be either 0 or 1, in this case 1. Okay, so there are 4 possibilities. Current input symbol also either 0 or 1, top of the stack also either 0 or 1. So if the current input is 0, top of the stack 0, we need to perform push operation. Current input is 0, top of the stack 1, again we need to perform push. But here the top of the stack is 1. So 1 replaces 1, 0 should be pushed onto the stack. And the current input may be 0, 1 and top of the stack is 0. In this case 1, 0. We need to push 1. Then current input is 1, top of the stack is also 1. So 1, 1. So these two transitions are used for pushing only one symbol onto the stack, and these are the recursive repeated steps for pushing the remaining symbols onto the stack. Then we will see. So by following these transitions, in this case 1 and 1 are pushed onto the stack and here 0, 0 are pushed onto the stack, right? Now the current input is C. So initially 0, 0 is pushed onto the stack, then 1, top of the stack is 0. So 1, 0 means 1 is pushed onto the stack. Then again 1, top of the stack 1. So 1, 1. So this 1 is also pushed onto the stack. Now the current input is C. So from Q0 to Q1, if C is the input symbol and the top of the stack may be either 0 or 1. In this string, top of the stack is 1. If we consider this string, top of the stack is 0, right? After pushing all symbols of W, then 0 will be on top of the stack here. So either 0 may be the top of the stack or 1 may be the top of the stack. So in this case, we need to perform no change operation. So 0 should be replaced by 0, 1 should be replaced by 1. just we are going to change our state from Q0 to Q1. Now the next input here is 1 and here is 0, right? So in Q1, if the next input is 1 and the top of the stack is also 1, means we need to perform pop. Sometimes in Q1, next input is 0. In this case, definitely the top of the stack should be 0. Then only we can perform pop operation. So this is repeatedly performed. So 1 and 1, so pop, 1 and 1 pop, 0 and 0 pop. Repeatedly it will be applied. So now Q1 and Z0. In this case 0 0 0 0 1 1. So now Q1 and the current input is epsilon here, epsilon, and the top of the stack is Z0, means we can replace the Z0 by epsilon and we should enter into the state Q2. So in the non-deterministic PDA, so this is non-deterministic PDA, here we have seen epsilon. So in each and every case, we will have whether to follow this, any one of this or this. But in deterministic PDA, here C is given. So whenever we see Q0 0 0, then we need to perform definitely push operation. Whenever we see Q0 C 0, we have to do the state change. This transition should be followed. So this is an example for deterministic pushdown automata. Here there is no choice in any path. Thank you.